So, question 18, on the grid, draw the graph of y equals 2x minus 1. Y equals 2x minus 1. Now, the easiest way to do this, there's a few ways to draw this graph, but I think the easiest way is to do a table. Okay, so I'm going to do a table. And this can be x, this can be y. Now our x-axis goes from -3 to +3. So I'm going to start at -3, -2, -1, 0, 1, 2, 3. And then I'm going to work out what my y values are using this formula. Okay, and what we're going to do is we're going to what we call substitute these values of x into the formula here. So we're going to replace, for instance, for the first one, we're going to replace this x here with -3, and then see what we get out for y. Okay, so as we do that, we'll get y equals 2 times -3 and then -1. Now 2 times -3 is -6, -6 minus 1 is -7. Like that. The next one would be 2 times -2 minus 1, and that would give us 2 times -2 is -4, -4 minus 1 is -5. Okay, and the next one will be 2 times -1 minus 1, which will be -2 here, -1 is -3, and so on. And if we keep doing that, we'll find that we actually get that. Now, so that I'm going to plot this graph, actually no, I'll leave those up there, that's fine. I was going to rub those out, but we'll leave them there. They're not going to interfere. So let's plot this graph now. So the first point will be this one, when x is -3, y is -7. Okay, when x is -3, that's here, y is -7. So that's here, isn't it? So so it's where those two cross, so you're talking about that point there. Okay. The next point is when x is -2, y is -5. When x is -2, y is -5, so there's one there. Okay, the next one will go here, the next one will go there, and the next one will go there, and there, and the final one there. Okay, then all we do is we plot that line. Let's go for a nice green line, shall we? And there we go. Okay, so just get rid of that. Or maybe not. Oh, there we go. Okay, so the total for that was 4 marks for an easy graph like that, so that's good, isn't it? Right, okay, question 19. In a sale, normal prices are reduced by 15%. The normal price of a television was $640. Work out the sale price of the television. Okay, now with percentages, there are just about as many ways of doing these problems as there are pupils. So, I'll just go through a couple. Reduced by 15%. Okay, well, let's see. I could find out what 1% is. Yeah. Or I could work out what 10% is. Maybe 10% would be good. So let's work out what 10%. 10% of $640 is well, we just to find 10% of anything, we just divide it by 10, don't we? So that would be $64. Okay. Now, if 10% of $640 is $64, then 5% must be half of that. Because, 5% is half of 10%, isn't it? So if we halve this, we get $32, don't we? Okay. Then we could add those up, and we end up with $96. So 10% plus 5% is 15%, which gives us $96. Okay. Then we could take that away, because the prices are being reduced. Okay, we need to take that away from the original price, which is 6. So we do 640 take away 96. Okay, which is $544, isn't it? So, okay, so that's $544. Okay, now that's the first way of doing it. It's perfectly fine, nothing wrong with that. Let's try and think of a different way of doing it. If I start with 100% and I take 15% off, what do I end up with? Well, I end up with 85%, don't I? Now, what's 85% as a decimal? Well, we just divide this by 100 and we end up with 0.85. Okay, so if I do 0.85 times by 640, okay, that is the same as taking away 15% of 640. And if I do that, lo and behold, I get $544. Okay, so that's quite, with a calculator, this is quite a nice way of doing it. So I like this one. This one's a little bit more work, but it's absolutely fine, no problem at all. So that's $544 for that one. Okay. Okay, this is a probability question. John throws a biased coin 120 times. It shows heads 90 times. John throws the coin once more. Work out an estimate for the probability that the coin shows tails. Okay, well, if it's let's see, it's shown heads 90 times out of 120. So the probability of John getting a head would be 90 out of 120. Okay? Now that must mean then that the probability of getting a tail must be, well, if 90 120ths is probably getting head, then that must mean there's, what, 30 120ths left? Okay? So what I'm doing is, I'm realising that that this and this must add up to a whole one. Must add up to a whole one. So if this is 90 120ths, this must be 30 120ths, because if we add those up, we get 90 plus 30 is 120 120ths, and 120 120ths is one whole one, isn't it? So the probably getting a tail is 30 out of 120. I'm going to cancel that down. I'm going to divide by 10 first of all, which means that these will go. Okay, and then I'm going to divide by 3. Divide that by 3 and divide this by 3, and I will get 1 out of 4, 1/4. Okay. Carly throws the same coin 200 times. Work out an estimate for the number of times the coin shows tails. Now this is a bias coin. Okay, so we have to stick with the probabilities that we've been given here. Okay, there's no point thinking that, oh well, the probability of getting a tail is half, because for this coin it isn't, because it's biased. Okay, if it was fair, it would be a half, but it isn't. So what we're getting here is that the probability of getting a tail, we've already worked out here, is a quarter. Okay. So that means that 1 in every 4 coins will be a tail. Or you could think of it as a quarter. A quarter of the coins should be tails. So in other words, all we need to do is find a quarter of 200, isn't it? So if we do 200, you can either divide by 4, or you could times by a quarter, or whichever way you wanted to do it. But either way, you will get 50. So we would expect to get 50 tails. Okay. Right. And on to the next video.